to find the sum, difference, and product of two functions. And this is exactly what it sounds like, but there's some notation confusions every once in a while. If I want to take two functions, f of x and g of x, and add them together, sometimes we write this f plus g, because when I get done, it's just one function, and the function is f plus g of x. And then, just for shorthand, we also just write f plus g and leave the x out of it altogether. But it's understood that f and g are functions of some variable. Traditionally, we use x. It is also true that f of x minus g of x is equal to f minus g of x, and that is sometimes written just f minus g. Okay, for the product, we have to be a little bit more careful because this circle has to look different than a circle that's open like that. That means something different. So f dot g, the product of f and g, well, I should write this in the same order that I wrote the others. F of x times g of x is also written f times g of x, and sometimes just written fg. Quotient isn't included in here because quotient has different issues for the domain. So I'm asked to find f plus g of x, f minus g of x, and evaluate f times g of 2. So f plus g of x is just f of x plus g of x. So this is x cubed plus 4x squared. Sometimes there are like terms you can combine and simplify. In this case, there aren't. F minus g of x is equal to x cubed minus 4x squared. And then f times g of x is equal to 4x to the fifth. We multiply them together. So f times g of 2 is 4 times 2 to the fifth, which is 32. And that is 128. Notice that f of 2 is equal to 8. And g of 2 is equal to 16. And 8 times 16 is 128. That will always hold, that if I evaluate the individual functions and then perform the combination, I get the same answer.